Okay, yours truly, Professor Dr. Dolphy Gilpin, and we are going to be focusing on here now xenon, which is a noble gas. It's right across the table from iodine, 53. So it's like 54, I believe, yeah. Yeah, it's 54 and 131. Xenon, Xe, 54 and 136 point something. We'll confirm that in a moment. And it is right across in the same period as iodine. And let's see, a noble gas. But this is one of the noble gas that has, though it's rare and noble, it has a certain amount of reaction. So let's look at xenon. So here we have xenon now, atomic number 54, and atomic mass of 131.34. That's a correction. 131.34. Xenon. And you will see the many isotopes it has when we come on to that section. It has many stable isotopes and some radioactive isotope, I believe. Let's see. Xenon 54, 131.34. So let's look at our notes here now for xenon. Okay, shell's configuration will be 2, 8, 18, 18, and 8. That will be one more than iodine, which is 2, 8, 18, 18, and 7. But iodine is 53 and this is 54. So it's 2, 8, 18, 18, and 8. And 131.293 with atomic mass number of 54. And noble gas configuration of 4d10, 5s2, 5p6. It was discovered in 1898 by, let's see, they are very precise here, July 12, 1898. They said this xenon was discovered. And we have how much? 37 isotopes of xenon. And xenon 110 to xenon 145, I think they are the stable ones. You have 9 stable isotopes. Xenon 124, xenon 128, these are the atomic weights of the isotopes, of the stable isotope. Xenon 130, xenon 132, xenon 138, xenon 126, xenon 129, xenon 131, and xenon 134. 9 stable xenon isotopes. And by definition of isotope, we know that each of these isotopes will have the same atomic number, but different atomic weights. And we have just shown you the different atomic weights. But all of these will have an atomic number of 54. That is 54 protons, which is the definition for the atomic number. And usually the number of protons equal the number of electrons. So we'll have 54 electrons. Okay, xenon will react with fluorine. As you know, fluorine is one of those reactive halogens that will react with everything except for helium and probably argon, I believe. 2 of those noble gas. But here we are. It can form compound with hydroquinone and phenol. This noble gas can be oxidized by group that are extremely electronegative. Yeah, so the very electronegative elements, extremely electronegative elements, will oxidize the xenon, forming salts. Now the formation of xenon hexafluoride. Hexafluoroplatinate. Hexafluoroplatinate. The first noble gas compound to be synthesized. So here we have a history here. They say that the first noble gas compound to be synthesized was the hexafluoroplatinate, xenon hexafluoroplatinate. So xenon is colorless, odorless, and it's not combustible, non-combustible gas. And we could have a reaction of xenon in a sealed vessel. We have xenon tetrafluoride here, XeF4, xenon tetrafluoride, reacts with hydrogen to give now xenon gas and hydrogen fluoride. So we'd have to have that reaction in a sealed container, in a very sealed vessel. Xenon tetrafluoride reacts with hydrogen gas to give xenon gas and hydrogen fluoride, and it also gives Xe gas plus another reaction with Xe gas plus hydrofluoride gas. And xenon can form compound with hydrogen, oxygen, and nitrogen. Yeah, so those in the real gas or noble gas or inert gas, it seems to be a lot of reaction can be obtained from this xenon. It's react with oxygen, hydrogen, and nitrogen, forming compounds with those. So here we have xenon F6, XeF6, xenon hexafluoride. That's another compound that can be formed from xenon. And in a reaction with xenon hexafluoride, we have XeF6 plus hydrogen gas yield hydrogen fluoride plus xenon. So you could, from a xenon compound, you could get xenon being isolated from this hexafluoride. Xenon hexafluoride, XeF6 plus H2 gas will give you hydrogen fluoride plus xenon. Okay, more reaction here. We have 2 xenon plus 2 fluorine give you 2 xenon, like difluoride or XeF2, xenon fluoride or difluoride. And XeF2 plus further fluorine will give you xenon tetrafluoride, XeX4. And XeS4 will further react with water. So with the XeF4 plus water will give you xenon plus oxygen plus hydrogen fluoride. And the evaporation of solution of this give you this xenon oxide compound here. So you have some by evaporation from the reaction with xenon tetrafluoride and water. When you cause it to evaporate, it will leave xenon trioxide, it seems, XeO3, or xenon 3 oxide. Yeah, so there are so many reactions here with this noble or inert gas. We have xenon does not react with oxygen directly. It reacts with water molecules to form xenon oxides. So it does not react with oxygen directly, but oxygen in combination with water, xenon will react with the water molecules to form xenon oxides. So there we have it, an introduction to xenon and its reaction. Atomic number 54, atomic mass of 131.4, having 9 stable isotopes and about 37 different isotopes there, but 9 of them are stable. And a shell configuration of 2, 8, 18, 18, and 8. That's for xenon.